Okay, continuing along, we just finished problem number 2. And by the way, I need to correct myself. In the previous problem, 36 times 8 is, when you do the math, is 288 minus 144. And the correct answer was 144 pi. I apologize for that. But the process is the same. The process should be clear. I feel that I've taught it to you. If you get it on a test, you should be able to do it. Okay, now we go on to number 3, and now we're doing the ratio problems. The ratio problems were explained to you yesterday, so we have some practice ones, easy ones again, choosing nice numbers. We're going to be canceling. We look at number 3, a cone, random, divided by a sphere. We want to know the ratio of the volume between these two objects. Okay, so I set up and plugged in the data for you. And you notice where the r is squared, and the height is 9. The radius is 3 cubed, because, as I repeat again and again, a sphere doesn't have any height. And now we're ready to work and find the ratio of the cone to the sphere. So I'm working along here, and the first thing I do is cancel the 9 and the 3. And I have pi times 16 times 3, and I'm going to leave it just like that. Okay? We'll come back to the work in a second. Never put the numbers together. You're looking to cancel if you possibly can. I move on here, and one of the 3's here cancels, and this goes away. Or if you like, 27 divided by 3 is 9. And when I write this out, I have a pi, I have a 4, and I have 2 3's. Does everybody see what I did there? Okay? And now, as we work along here, 4 goes into 16 4 times. The 3's cancel. As previously explained, the pi's cancel. And the ratio is 4 to 3. That was the correct answer. All right? So you should have been able to come up with that by hand. Calculator would make it a million times worse, more difficult to understand. Okay, we go on to the second one, and it's the same exact idea. Again, be careful about diameter. I took half of the diameter and turned it into 8. There's the height, which I wrote, and that's divided by a sphere as well. No height in a sphere, just 6 cubed. And we write it out going left to right. And I write pi 12 divided by 4. And over here, I better slow up for the weaker students. I have this, okay? So immediately I have that. Okay, so the 3 went away. And now we can put everybody in order. We can cancel the pi's. It's easier that way, less clutter. And we have 8 times 8 times 12 divided by 4 times 2 times 6 times 6. And I pause there for a second so you can see what I did. Now, 4 times 2 is 8, so these two guys go away. 6 goes into 12 twice. Let's just slow it up for a second. What's left that hasn't been canceled or crossed out, 8 times 2 divided by 6. But there it is. It's an 8 to 3 ratio, and I'm hoping that you easily could have come up with that. The analogy to the prisms is precise. It's the same thing, same idea. They want you to be able to do that. Okay? So I'm going to erase this now. Feel free to send me any feedback you want. Notice I corrected the answer for number 2. It's 144 pi. And now I'll go on to problem number 5. It's a word problem. I'll read it out since you're supposed to have a copy. And it says, find the ratio of a cone. So I draw a cone. R equals 4. H equals 9. To a cylinder. And they'd expect you to be able to do something like this. You take the words, to set them up, put them over here naturally, and R equals 3 here, and H equals 8. So I got to come up with some sort of work here. So let's see, we have 1/3 pi r squared times 9 divided by pi r squared times h. Immediately we do this as we've done before. We're starting to see how easy the problems are. The pi's are canceling now, and we have 16 times 3 divided by, oops, I wrote R3 there. I was supposed to write 3 squared, okay? And then we write that on the bottom, and we have 3 times 3 squaring the 3, and the 8, and now we're working, and what's left after we cancel the numbers easily, you should make sure you can do this. The ratio of the cone to the cylinder is 2 to 3. For every 2 cones, the volume, there are 3 cylinders. All right? And I want to do one more problem that I've given you Monday. And this problem's a little more complicated. As time goes on, I'm going to try to work in more complicated problems. So the stronger students have a little bit of challenge. They can work on these things. And so this is telling you that a cone has a radius. And this is the problem I gave you on Monday. It says that a cone has a radius of 4 units. So there's the 4 for the radius. And a height of 5 units. Here the numbers are not meant to work out as nicely. If the radius is decreased by 1, so we make a smaller cone. We imagine a smaller cone. So the radius is decreased by 1. 4 minus 1 is 3 over here. And the height is decreased by 2. 5 minus 2 is 3 over here. But what is the difference between the original and the new? And you'd be expected to do these kind of problems. So again, we'll write it out. It might be getting old for a lot of you. There's pi. The radius is 4 squared times the height. Oh, we can't cancel this time. We'll have to think about that, won't we, guys? And over here, we have 1/3 pi again, and then 3 squared times 3, and we immediately get rid of the 3's. So when we write everything out, going left to right, we have 1/3 pi. Obviously, when you do difference, pi is going to be in the answer. You're requested to do this in terms of pi. So I have 16 times 5 minus, and over here, 9 pi. So this could never be an answer like this. You'd have to go back to 6th grade and write the equivalent of 9 pi with a 3 on the bottom. You were taught this in 6th grade. If you forgot it, now you've seen it again. Well, 9 pi is perfectly equivalent to 27 over 3 pi. Notice I did that so I can make it one number and then do 6th grade math. And so over here, I have 80 pi, because 16 times 5 is 80, and 3 on the bottom. So 80 minus 27 is 53 pi, and over 3, of course, because when you're subtracting, the denominator stays the same. And to give it a proper answer, I divide 3 into 53 to get my mixed number. And when I do that, I come up with 17 2/3. The pi had 17 2/3 pi. Notice that my 17 looks strikingly similar to pi. So we'll make that like that. And that, again, would have been the correct answer to that. And again, the only minor difference is that I had to turn 9 pi into 27 over 3. Reason, I can only subtract improper fractions if the denominator is the same to get one answer. And you'd probably be expected to turn this into a mixed number here. So there's the correct answer for that one. Okay.